All right, so we need to take 0.865 and subtract 0.800. Now, if you're listening to this and you are bored because you already finished it, there's a big sig fig review on 2.2e, which is on page 42. So if you're like, I do not need to listen to number 11 because I already know how to do it, you can go to page 42 and start doing the big sig fig review. Okay. 0.065 minus 0.800 gives us 0.065. And our uncertain digit is in the thousandths position. It's in the thousandths position, so it is in the thousandths position, okay? This number over here, 1.59. Oh, I need a calculator for this one. $1.593 plus 9.04 equals 10.633. Thank you. And our uncertain digit in this one, we have the thousandths position and the hundredths position. So we have the hundredths and the thousandths. Okay, so now we are going to multiply these two numbers. And when we are multiplying, we are no longer looking at the uncertain digit. We are looking at the number of sig figs. So this number has 2 sig figs, and this number has 4 sig figs. I'm not going to get rid of that 3 just yet, because if I do, I might get a rounding error. Okay, so I'm going to take 0.065 times 10.633 equals, and my calculator spits out 0.691145. Because it was a multiplication, I need to go to the smaller number of sig figs, which is 2 sig figs, which means that's going to round to 0.69. Is good? Okay, cool. Any other questions that anyone would like to go over? Yes? It will include everything up to and including the double black diamond, but of course, black diamond and double black diamond are optional, right? So if you choose to do them, that's great. But if you get them wrong, it does not matter. It will not count against you, okay? Only the regular questions. So good question. Anything else? Okay, so that big sig fig review, you can feel free to do as much or as little of that as you need to prepare for it. I'm not going to give you time to do that now because we need to move on. And we will be moving on to our next topic, which is unit conversions, 2.3a on page 46. I really wish that I could give you a color copy of this because it is so much more beautiful. However, we make do with what we've got. We are going to have 3 abbreviations. U is going to stand for the unknown, which is what the question asks you for. I is going to stand for the initial quantity, which is given in the question. So when you're looking for the unknown, you're going to look for the question word. How many centimeters? that kind of thing, okay? How many, what is the mass of, okay? So we're going to have an unknown, we're going to have an initial, and we're going to have a CF, which stands for a conversion factor. Anyone worked with conversion factors before? Yes? Okay, a few of you. So a conversion factor is basically where you have two things that are equal to each other. And what you do is you put thing A over top of thing B. All right, and that's what a conversion factor looks like. It looks like one thing over another thing. So that tells you how we are going to attack these problems. It won't make sense until we've done some of them, okay? So if we have how many inches is equal to 2 yards, I'm actually going to do this over here, but it's all written down for you if you want it, okay? How many inches is 2 yards? Well, what is our unknown in this question? Tell your partner. How many inches? So we're going to say we don't know how many inches. That's our unknown. What is our initial quantity? And that's what you're given in the question. Two yards. Okay, so we have 2 yards. That is our initial quantity. That's what's given in the question. I could have called these things the given, but Hebden calls it the initial quantity, and I wanted to be consistent with what Hebden does if you use that for extra problems. Okay, so our initial quantity is the 2 yards. So we have 2.0 yards. All right, and finally, we need a conversion factor. And remember, in a conversion factor, we have two things that are equal. Do we have two such things in this question? Yes, we do. We have 1 yard is equal to 36 inches. That's going to be our conversion factor. And remember, how do we write it? We write thing A, 1 yard, over thing B, 36 inches. Now, when you start to get good at this, you can stop writing these all out at the beginning and just start throwing them into an equation. But while you're starting out, I would really recommend writing down U equals, I equals, conversion factor equals. That way you've got them right there and you won't get confused, okay? Now, how do we do the calculation with these things? We take our unknown and we say, my unknown is equal to my initial quantity times the conversion factor. Okay? Another way of saying that is U is equal to I times CF. And you can write that down for yourself if you find it helps you structure the equation. Okay? So our unknown was the number of inches. So we don't know how many inches. That's our unknown. Our initial quantity is 2.0 yards. It's not a very nice 2. And then we are going to multiply by times a conversion factor. And remember, up here, there's our conversion factor, 1 yard over 36 inches. 1 yard over 36 inches. And I'd like you to take note of how I've structured this. The 2.0 yards is technically in the numerator, even though there is no denominator, yes? If you wanted to, you could write over 1, just to show that there's something on the bottom there, okay? And then I'm going to look at this and I'm going to say, oh, this isn't going to work. What would I get if I did the question this way? What would my unit be? I would have yards times yards over inches. Do you see why we spent some time fussing around with units earlier? It's so that you can recognize that this would be yards squared over inches. Did I, in fact, solve for inches? No. So, although my method is unknown is equal to initial times the conversion factor, conversion factors can be written either right side up or upside down. And it really doesn't matter. So when I say we have a conversion factor, if I write 1 yard per 36 inches, I could also say 36 inches per 1 yard. And I need to pick the format that will cause my units to work out properly. Okay? So let's take a look at this again and let's try the other version of the conversion factor and see if that does us a little bit better. So we don't know my unknown, the number of inches, is equal to my initial quantity, 2.0 yards, times, and now I'm going to put 36 inches per 1 yard. And now I go, oh, do my units work now? Yes, they do. Okay, so 2 times 36 is 72. Sig figs? Are those correct? Yep. How many sig figs in 2.0? 2 sig figs. How many sig figs in 36 inches? Infinite. How many? No worries. How many sig figs in 1 yard? Infinite. Because this is inches are imperial and yards are imperial. Okay? And if you're not sure, you can always ask.
We are now calling grade 9 students with the last name beginning with D and E. Please go to the multi-purpose room for immunization. Last name beginning with the letter D and the letter E. Please go to the multipurpose room now for immunization. Thank you.
Now, can I tell you something? When I actually set up a problem like this, and I'm not doing it with you guys for the first time, what I would actually do is I would say, how many inches is equal to 2.0, and I'm going to use the abbreviation for yards because I'm getting tired of writing the whole thing, times, and I would just draw a line. And then I would say, what unit do I need to cancel out? I do not want yards. I need to cancel yards. And that means, where does yards have to go? Does yards go on the top or on the bottom of the conversion factor?
Bottom.
Goes on the bottom of the conversion factor. So I'm not going to accidentally write it the wrong way around if I do it this way and I fill in the units with like a little bit of brain action going on at the time. So I'm like, yards must go on the bottom. That means inches must go on the top. And I know that there are 36 inches per 1 yard. Okay, is good? All right. Okay, we are now on page 48, and this is just a bunch of blah, blah, blah. If you believe me that dimensional analysis, this is called unit conversion, if you believe me that it is the most powerful tool you will learn in Chemistry 11, and that you promise, cross your heart and hope to die, that you will use this method when it is asked for, and not some other wackadoodle method, then I don't have to read all of this to you. Do I need to read all of this to you? Yes? Okay. Because honestly, every year there's always someone who's like, I don't need to use dimensional analysis. Do you guys know, what's his name? Manning Watson in grade 12? Yes, okay. So Manning, very smart boy, okay? He's like, I don't understand why I need to use dimensional analysis. He's like, I don't get it. So he did the first 4 tests. He did the first 4 tests in Chem 11, did fine without it. He did learn how to do dimensional analysis, unit conversion for this test. And then he was like, I'm just going to throw that out. Then he got to the mole unit. And he was like, I'm just going to solve these problems my own way. And all of a sudden, he started getting stuff wrong. And he's like, what's going on? And I said, how about you try using unit conversion? He's like, no. And I'm like, just try it. See how it goes. Because he did understand how to do it. He was just resistant. All of a sudden, he's like, oh, this makes so much sense. I see why you would use it. And this happens every year. Ms. Wu and I, we spend so much time telling people unit conversion is the way to go. Literally, I have had students come back after graduation and tell me they have used it in their everyday life, right? I had someone who was training for races and they were using it to convert their times and things like that. Okay. My husband and I, we both use it in our daily lives, not just for school or work. If you know it, it is an incredibly useful tool. Learning a skill works better when you first learn and practice it in a simple context. So you will find that the problems we do right at the start, you'll be like, good gracious, this seems like a waste of my time because I could do this in my head. Yes, I know you could do it in your head. But you need to learn the method by practicing it on something really easy, okay? You can easily see if you've made a mistake if you use unit conversion. It makes your work clear to your audience, which is really important because when I'm marking something, I need to be able to see, where did you go wrong? If I can see where you went wrong, I can probably give you part marks. If I can't see where you went wrong, I'm just like, oh, if you get it wrong, the whole thing's wrong. Bye. All marks gone. It makes solving complex problems manageable. Halfway through the course, you might get a question like this. What volume of 4 mole per liter HCl must be reacted with zinc to produce 3.5 liters of hydrogen gas at STP? This is unit 5. And look, we have a conversion factor that you will learn. we have a conversion factor that you will learn, and we have a conversion factor that you will learn. You will know all of these conversion factors, and you'll be like, I can go from liters to moles of H2 to moles of HCl to liters of HCl, and I can do that because I can convert units. So powerful. And look, that's all just solved in one line, and it's so pretty and so lovely and so gorgeous. And if you write it like that, my heart will sing. Okay? I'll be like, oh, happy, happy teacher. Okay? But we're going to start with some very basic things that you could do in your head. Let's do this one here, because sometimes the conversion factor will not be something given in the question. Sometimes it's something you are expected to know. How many days is 360 hours? What is your unknown? Number of days. I don't know how many days. What is your initial quantity? 360 hours. And I'm just going to put H for hours, okay? And what is the conversion factor between hours and days? There are 24 hours, whoops, in one day. Now remember, you could write that conversion factor as 1 day per 24 hours. You set up your problem by saying my unknown is equal to my initial times a conversion factor. So my unknown, and you should write the unknown, you should write what you are solving for so that you know when you get to the end of the question, your units match up. What was I solving for? Did I get that unit? Okay, so always write the unknown. I don't know how many days. My initial quantity is 360 hours. My conversion factor is going to be a line. And now I'm going to put in the units before I even put in any numbers. Where should hours go in order to cancel out? It should go on the bottom. So hours are going to go down here and days are going to go on the top, which is lovely because where do I want them? I want them on the top. Yes? So that's a good thing. All right, and there's 1 day for every 24 hours. 360 divided by 24 is 15. And my hours have canceled out, so I should cross them out. When units cancel, I should cross them out. And then I write day. Okay? So there are some exercises here. You are going to use dimensional analysis, also known as unit conversion. Why do I use that big long word? Because if you go on to study at university, they might call it that and you might as well have heard it before. Okay, but if you want to call it unit conversion, that's fine. Remember that defined conversion factors have infinite sig figs. 60 seconds, 1 minute, infinite sig figs because they are exact. So give these a try. I'll give you, 10 minutes or so to work on that. Make sure you show your work. I'm going to come around and see if you have shown your work, including canceling units. Yeah. Who is away today? Hannah is away today. Yes. Yeah, for sure. It's February 29th. Nobody has a birthday today, do they? Kind of exciting day, only once every 4 years. Leonardo, Jim, Asim, Crystal Wilfred, Nathan. Yeah, it's just. Okay, good stuff.
I don't know.
If you want to, it's fine. Okay, but you don't. That one. Yes, there's another page. If you didn't finish 48, go on 49.
For number 6,
Yes.
it's a little bit confusing about how it works. Is the unknown the cost of $2,000?
Yes.
Okay, so the initial will be $2, huh?
No,
$2.
2 dozen.
Oh, that's why, that makes sense.
Yes. And you don't actually have to write cost per 2 dozen, it's just a cost.
Yeah, okay.
Sometimes people do weird things like they'll do the cost and then they'll divide by 2 dozen and then it gets confusing. You know what I mean? Like, so just,
Okay.
yeah. Because that, you're looking at how that, okay. Okay, so we have $1. Okay, so you want to find hours. Which one is the conversion calculation? Absolutely, yeah. On the right, yeah.
Oh.
To the correct, yes. But, if you have material, material, conversion value. Whatever.
Yeah, they do use.
Yeah. Yeah, that's correct. Yeah, yeah. Yeah.
Saving breath. You have
Please continue construction. We are now calling down grade 9, last name beginning with the letter F and the letter G. Please go to the multi-purpose room for your immunization shot. Grade 9 student, last name beginning with F and beginning with G. Thank you. That looks less. Is the green one. That's okay. Okay, so we have a few little issues here. Well, number one, we feel like in the sound too, is that really an equal sign? Does it really need to be put like four? Oh, that's as fine as that. Okay, so yeah. And then, because make sure you. That includes. Make sure every number. Yeah. Thank you. Okay, everything that we make. So we want to pause, see $100. That's this one. And our initial one, in going to those. Now, we're going to do oh, no, there's, what? Yeah. Well, how many siblings are three? Okay, and then you are now. Yeah. Right?
Never. Yeah. I don't know. I'll give you
Is there anyone whose work I haven't seen yet? I know I haven't like sort of hit everyone. Excellent. Yes. All right. Yes.
How I did it was 670 kilometers divided by 80 kilometers over 1 hour. Kilometers. That doesn't look too different.
Square. You're multiplying seconds by seconds. Seconds squared divided by. What does that tell you? That tells you that you're it's upside down.
Yeah.
Seconds on the clock, so you don't cancel it. Yeah. So you picked one. That was this one here. Well, this happened, I forgot. 360 hours. First of all, there's not.
It's OSHA.
Yeah, so always make sure the word you have here. Finish round to press it, yes. Why is it exact? Because when you're converting between two different units, so all of those action are imperial.
Okay, so metric is used by most of the world for measurement. But if you live in the United States, they use imperial meters. So those are inches and pounds and things like that, those are the imperial meters. But we, most of the world use millimeters, kilograms, and centimeters. Okay, now, whenever you have, so between those two, the one that says one will be exact, and the one that says the other, that's the one kind of thing you'll. If you have both in the same weight system, both are immaterial, then they will be exact. What is a not, it is. Okay, so this $1.44 is not on its own. It goes along with the dozen. You know, that's your conversion factor? Yeah. So you might get your initial and your conversion factor. What are you trying to find in the options?
How many?
4 please. Perfect. Thank
1,
you.
2, 3, and 4.
Thank you so much.
Go. All right, most people are doing pretty well. I want to give you one more tip that might make things easier, especially when we get into multiple conversions. Let's look at example number 6 for, let's look at number 6 for an example. The unknown and the initial will be connected in the sentence. What do I mean by connected? I mean, what is the cost of 2 dozen eggs? I want to know the cost of what? I want to know the cost of 2 dozen eggs. So that means that my 2 dozen eggs must be my initial quantity. So if you're having trouble finding the initial quantity in the question, like a lot of people get down to this one and they get a little bit confused, right? Because there's like numbers, there's a lot of numbers. Which one is my initial? First thing you can know is that a conversion factor always has to have 2 things, 1 unit and a second unit, one over the other. When we write like this, that puts 1 over the other. But when you write it as a conversion factor, you will never write it like this. You will always write it as either 80 kilometers over 1 hour or 1 hour over 80 kilometers. So that tells you that that is your conversion factor. But the other way to tell that the initial is not 80 is you can look and you can say, how long? What is how long attached to in that sentence? Is how long attached to 80 kilometers or is how long attached to 670 kilometers? Which 2 ideas are connected? Nobody is answering me. Are you kidding me? Which are connected? How long will it take to go 80 kilometers per hour? Or how long will it take to go 670 kilometers? 670. These 2 ideas are connected. So that means that our unknown is connected to the initial. Now, sometimes in a question, they won't be right beside each other. One might be at the beginning of the sentence and one might be at the very end, and you might have a conversion factor given to you in the middle. But if you read the language carefully, you should be able to figure out where things are. Look at that. English coming into chemistry. Whoa. Okay. Next, 2.3b. Ooh, it looks like I used this last year. There is a Tyler DeWitt video, so if you're having problems, feel free to reference that when you get home, okay? There is a series of steps here that I am not going to go through because we are just going to go through them together, okay? And I'm just going to get rid of this. Hang on a second here. Okay, there we go. Good, good, good. So we are going to start with example 1. How many seconds are in 1 day? So this is on page 51. How many seconds are in 1 day? Now, does anyone know a conversion factor between days and seconds? You do. Okay, if you happen to know that, then you may use it. But most of us do not, okay? So what we're gonna have to think to ourselves is we're gonna have to think about the fact that my unknown is how many seconds, and my initial quantity is 1 day. And what you can do is you can make a map of the problem. If I'm starting with 1 day and I wish to finish with seconds, what could I convert days into that would get me closer to seconds? I could convert it into hours. Some of you may know a conversion factor between hours and seconds. We're going to pretend that nobody does. Okay, if you happen to, you could use that and save yourself a step. I want to show you several steps. So what could you convert hours into to get closer to seconds? Minutes. And then from minutes, you can go directly to seconds. So what this means is you are going to do 1, 2, 3 conversions. So this is going to be a 3-step problem. And that means if you have 3 conversion factors, if you have 3 conversions, you will need 3 conversion factors. All right. So conversion factor number 1. What's one conversion factor that we need? Probably for here, going from days to hours. 24 hours per day. Conversion factor 2, going from hours to minutes. Oh my God, 60 minutes per 1 hour. Okay. Conversion factor number 3, going from minutes to seconds. There are 60 seconds per minute. Okay. Now, when I set this up, I'm going to have my unknown is equal to my initial times a conversion factor, but I'm going to need to multiply by 3 conversion factors because I have 3 steps. Yes? So what I'm going to do is I'm going to say my unknown is seconds. I don't know how many seconds. My initial quantity is 1 day. My recommendation to you is, because you have 3 conversion factors, don't write in any conversion factors yet. Just write the following: times line, times line, times line. So write times line for every conversion. Second thing I would do is I would put in my units. I wouldn't necessarily even put in the numbers. I would just put in the units. So in step 1, I want to start with days and find hours. What has to go on the bottom of my first conversion factor to go from days to hours? Has to be days, so that days will cancel out. That means that hours go on the top. If I wanted to, I could put in my numbers now, but I'd actually rather just make sure my units all work, okay? If you get a number wrong, you only lose like a half a mark, but if you get your units wrong, that would lose a full mark, okay? All right, now I have hours, and I want to go from hours to minutes. So where do my hours have to go? Hours have to go on the bottom. And I want to find minutes, so minutes have to go on the top. I have minutes, but I don't want minutes. I want seconds, so minutes have to go on the bottom to cancel out. And then seconds have to go on the top. So now I can go through and I can say everything has canceled out except for seconds. So I wanted to find seconds. I have found seconds. Isn't that brilliant? Yay. Okay. So now we're going to put in all our numbers. There are 24 hours in 1 day. There are 60 minutes in 1 hour, and there are 60 seconds in 1 minute. So we plug that all in. 24 times 60 times 60 is 86,400 seconds. I'm going to assume I was asking for exactly 1 day. We'll assume exact. I'll make it more obvious if I give you a quiz or something, whether something is exact or not, okay? Alrighty, and that's our final answer. That's how many seconds are in a day. So, what should you do first? Probably draw a map saying, what am I starting with? What am I finishing with? What steps do I need to get there? Eventually, you probably will not need a map, but maybe to start with, it's a good idea. If you don't need one because you've already done this sort of thing, don't worry about it. I don't actually mark the map, but it's a handy tool. All right, one more question here, and then we will be done for the day. Okay, this is a real life question. This actually happened in my life. I had to do, you remember when I said I use conversion factors in real life? This was my real life example. I used to coach the debate team, and I needed to drive some debaters to a tournament in Penticton, and I needed to include the cost of the fuel in the cost of the field trip. So I looked up the distance from Penticton to Penticton, and I found that the driving distance was 403 kilometers. I had a 2002 Honda Odyssey, and I went and I looked up its mileage. I could only find it on a US site, so it gave me my mileage in miles per gallon. When I go to the gas station, though, I don't buy in gallons, I buy in liters. So I needed to go look up a conversion factor between liters and gallons. I also know my distance in kilometers, not miles, so I need a conversion factor between kilometers and miles. And you can tell how long ago this was because the price was $1.30 per liter. Okay. I think I may even have updated that price, but it needs to be updated again. It's really embarrassing. But anyway, how much will it cost to make the trip to Penticton? So here's the thing. Let's look for our unknown. Usually the unknown is the easiest thing to find because you look for the question word. So what is our unknown? Chat with your partner. What is the unknown in that question? How much it will cost. Okay, so that is our unknown. So we don't know how many dollars. Do you remember I said that the initial is usually connected to the unknown? What is connected to the unknown? How much will it cost to make the trip to Penticton? What do we know about the trip to Penticton? It is 403 kilometers. 403 kilometers. All right. Now we have a bunch of conversion factors. So I'm going to just write them all down. Conversion factor 1. I'm given 25 miles per gallon. So 25, I'm going to write MI for miles and gal for gallon. Conversion factor 2, I am given that 1 liter is equal to 0.26 gallons. Conversion factor 3, I am given that 1 kilometer is 0.62137 miles. And conversion factor 4, I know that it was $1.30 per liter. So we're going to make a map, not to Penticton, but we're going to make a map. What are we starting with? Our initial quantity is kilometers. So we're going to say, I am starting with 403 kilometers. Eventually, at the end, I want to figure out the dollars. What can I convert kilometers into? And that's why you've got all of your conversion factors listed. You say, I can convert kilometers. The only place I see kilometers is here. I can convert kilometers into miles. Okay, so I'm going to take kilometers and I'm going to convert it into miles. Now, I have miles there, but I'm not going to use the same conversion factor. Otherwise, I'd just be going backwards. Where else do I see miles? 25 miles per gallon, so I can convert miles into gallons. So I'm going to take miles and convert that into gallons. What can I convert gallons into? Take a look at your 4 conversion factors. Gallons can be converted into liters. And finally, oh my gosh, I have liters and dollars in the same conversion factor, so I can convert liters into dollars. So how many steps is this problem? It's 1, 2, 3, 4 steps. Okay, so we're going to start, and we're going to say my unknown is equal to my initial, and then I'm going to have 4 steps times a conversion factor, 1, 2, 3, 4. Do you need to write this bit here? The answer is no, but if it reminds you, you need to multiply by 4 things, you can do that. So how many dollars is equal to 403 kilometers, my initial quantity? Class isn't over for another 5 minutes, right?
I don't think so. Got 4 minutes.
Yeah, I got 4 minutes. Oh, that's tons of time. We're going to go 1, 2, 3, 4. What do I want to cancel right away? Kilometers, and I want to find miles. Excellent. Now I have miles, and I want to cancel that, so it's going to go down at the bottom, and I want to find gallons. Miles cancel out. Now I have gallons, and they need to cancel out, so they go down at the bottom. Gallons. Stupid pen. And I want to find liters. Now I have liters, so I need to cancel that out. And I want to find dollars. And now we just go through our conversion factors and we say miles per kilometer. That's this one here. So there's 1 kilometer for every 0.62137 miles. Do you notice how I had to turn that upside down from what I had written? Totally fine, not a problem. Gallons per mile. I have 1 gallon for every 25 miles. Again, I had to turn that one upside down. Now I need 0.26 gallons is 1 liter. And I know that 1 liter is $1.30. Okay? We throw that all into the calculator. And I'm actually going to cheat and just go back here because it is actually done for us. Okay, so you can see everything cancels out. We get $52.09. But we only have 2 sig figs here, 3 sig figs here. Yes?
I was wondering if that instance, it says that the conversion between gallons and liters is 1 to 0.25.
Oh, and it should be 2.6.
Yeah,
That's a typo. Okay. Let's just assume that I've done it correctly, like just for funsies, okay? And I need to fix this. Okay, so because really all I care is that you get the units right and you get the sig figs right. The actual answer itself is almost a sideline, you know what I mean? So, yes. So what you're going to do is you are going to do 2.3a, or actually, no, where is it? Yes. So you're going to finish off pages 49 and 50. And you're going to do questions 1 and 2 on page 54. So the homework, finish 49 to 50, do page 54, and study for your quiz. There we go.
With the owner of a gray Honda Fit, license plate JW932C, please let the owner of a gray Honda Fit, JW932C. Thank you.
Just wanna do a request tomorrow.
Okay, no problem. Good stuff.